All right, so in this video, we're going to continue with solving trig equations. So we've talked about it before. Our goal is to isolate the trig function and then do inverse operations to figure out which angles satisfy the original equation. All right, now we're going to build on that, but now we're going to have some quadratic trig equations. So instead of having like an x squared and x, we might have a sine squared and a sine. So just to recall how to solve those, all right, always try to factor a quadratic first. And you also want to have 0 on one side of the equation. So the first thing you do when you notice you have a quadratic equation, all right, x squared and x, or maybe just an x squared, is you want to try to get 0 on one side. All right, and that's already done for us. The reason why is because if we factor it, then we know that anything times 0 is 0. So we could set each factor equal to 0 and solve. Or if you can't factor it, you can do the quadratic formula, which requires you to have it in standard form to figure out what a, b, and c are. All right, so that's why I want to get 0 on one side first. So let's try to factor it. So this is leading coefficient is 3, and the constant is -2. So I'm seeing -3 times, or 3 times -2 is -6. All right, so that's A and C. All right, B is -4. Are there two numbers that multiply to -6 and add to -4? If so, then that means I could factor this. And after doing some thinking, I don't think there are those numbers. You got -6 and 1 and -3 and 2. All right, this one adds to -5, this one adds to -1. So you can't factor it. So we have to do the quadratic formula. So that is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, what's a, b, and c? Well, once it's in standard form, all right, a is a number in front of x squared, b is a number in front of x, and c is the constant term. So we have a is 3, b is -4, and c is -2. So if I plug that into the quadratic formula, I get +4 is equal to the square root of -4 squared, which is 16, minus 4ac all over 2a. So I have 4 plus or minus the square root of 16 plus, it's plus because it's a double negative. So it's minus 4 times 3 is 12 times -2 is -24. So it's minus -24, which is like a plus 24, right? All over 2 times 3, which is 6. And that gives me 4 plus or minus root 40 over 6. Now, I could quickly show you just how you could simplify this, and I will, just because I'm a math teacher. And then I'll show you that for trig stuff, we just want to put it as a decimal anyway. But let's quickly go over how we could simplify this. So root 40, first, that's a radical that could be simplified. That would be 4 times 10, and then 4 is 2 times 2, and 10 is 2 times 5. So if I'm looking for perfect square factors of 40, I know that 2 times 2 is equal to 4. So the square root of 4 is 2, so I can bring the 2 outside the radical, and I'm left with 2 times 5 inside the radical. All right, so now I have 4 plus or minus 2 root 10 over 6. So since all of these, 4, 2, and 6, they're all even, I could simplify 4 6 by reducing that to 2/3, and then 2 6, that reduces to 1/3. So my final two values of x that would work here is going to be 2 plus or minus root 10 all over 3. All right. Now, I could have just, if I wanted to get my answer as a decimal, I could have just stopped right here and typed this into the calculator. All right, so to get my two decimal answers, that's what I'm going to do now. So it was 4. It was, well, control division. Oops, first we got to add a calculator. Then do control division. You do 4 plus the square root of 40 over 6. And that gives me one solution. All right, 1.72. So that'd be one decimal approximation of a value of x that would work here. And then the other solution would be the difference, 4 minus root 40 over 6. Right? And if I just hit enter and I have a cast, it's going to simplify it. But if I want to get it as a decimal, I'll hit control enter. Right? Control enter gives me that approximated equal, and I get negative 0.387. Right? Now, again, it's good to know how to simplify and keep things exact, but for what we're about to do, you're going to want to know how to get decimal answers, because we're going to mainly be using the calculator once we solve the quadratic or get down to the formula, the quadratic formula. Right? So that's how you solve a quadratic when you can't factor. So now we're going to look at, well, how do you solve a trig equation when it kind of looks like a quadratic and you can't factor it? So let's take number one here. All right, we have 2 sine squared of theta plus 2 sine theta minus 1 equals 0. Right, so if I temporarily let the sine of theta equal x, all right, this becomes a quadratic. 2x squared plus 2x minus 1. So instead of my variable being x, it's the sine of theta. But to write less letters every time I do a step, I'm going to just write x. You don't have to do this, but it might help you. So if it helps you, do it. All right, now I'm going to try to factor this. Well, if I look for two numbers that multiply to AC, which is 2 times negative 1, and adds to B, all right, those two numbers don't exist, because if it's like negative 2 and positive 1, then that adds up to negative 1. And vice versa. If it was positive 2 and negative 1, it would add up to 1. So we have to do the quadratic formula. So now I'm going to type this into my calculator to do the quadratic formula. So I encourage you to do that as well, to do all the work. Let the calculator do all the work. So again, we're solving this right here. 2x squared plus 2x minus 1 equals 0. Right? If you don't have to type that. I'm just writing it so that you have it on the screen. So for the quadratic formula, it's control division. All right, it's the opposite of b. So negative 2 plus or minus. So first let's do plus, and then we'll copy it and do minus after. The square root of b squared. So it's important to put b in parentheses. It doesn't actually matter here, but if b is negative, when you square it, it should be positive. So if you put the parentheses, whether this is positive or negative, it'll do it the right way. So it's always good practice to put b in parentheses. Anytime you square something, if you put it in parentheses, it'll ensure that you square that whole value. All right, so b squared minus 4 times a times c. Okay? And I kind of wrote that weird, so I'm going to use the actual buttons so that you're not confused. I was using my keyboard, which you don't have access to if you have a handheld. All right, so 4ac, all right, all over 2a, all over 2 times 2. Okay, now I'm going to hit Control Enter, because with my calculator, if I hit Enter, it's going to simplify that for me. And I want to get a decimal approximation. You get 0.3660. Okay, so that's one of my solutions to this equation right here. All right. The other solution would be this, but instead of the opposite of b plus the square root of b squared minus 4ac all over 2a, we want to do the opposite of b minus the square root of b squared minus 4ac all over 2a. All right, and that comes out to be negative 1.366. Okay, so right now, I got the chime that someone's trying to join, but I don't see anyone in the waiting room. Anyway, so we just solved 2x squared minus or plus 2x minus 1 equals 0. And we got x can be 0.366 or x could be negative 1.366. Okay, now our original equation had, instead of having x, we had the sine of theta. So now what we have is the sine of theta could be 0.366, or the sine of theta could be negative 1.366. Okay. Now an important fact to know is that, like, if you think about y equals the sine of theta, like what could sine be? If you think about the graph of the sine of theta, right, it goes between 1 and negative 1. And if you think about the definition of the sine of theta as the opposite leg divided by the hypotenuse, all right, the opposite leg can never be bigger than the hypotenuse. So over h can never be bigger than 1. It could be at most 1. So sine of theta is always going to be in between 1 and -1. All right, same thing as the cosine of theta. All right, it's always going to be in between 1 and -1. So this equation here, I could tell right away, has no solution because you can't take the sine or the cosine of an angle and get anything bigger than 1 or less than -1. It's only going to be numbers between 1 and -1. All right, so for this, I could throw away this solution right here. All right. And again, if I went to go try to solve like the sine of x is equal to -1.366, all right, and if I went to solve that, I would do the sine inverse of -1.366. It would tell me undefined, no solution, because there's nothing you can take the sine of to get anything below -1. Okay, so now I have to try to solve this. The sine of x equals the other value I got, 0.366025. Right? Now, if I was solving that, if I was figuring out what angles you take the sine of to get this ratio, all right, I need to do the sine inverse of that ratio, which is 0.3660. That's enough. Okay. And if I'm in degrees, which my calculator is in degrees, right? And I know it should be in degrees because this part of the question here tells me I'm looking for angles in degrees. All right, if I do sine inverse, it'll give me the angle in degrees that satisfies this equation here. All right, so the sine of 21.4969, blah, blah, blah. All right, the sine of about 21 degrees is going to equal about 0.366. Okay, so that's going to be one of my solutions, all right? Because again, I took this quadratic and I couldn't factor it, so I did the quadratic formula, and I got that the sine of x could equal -1.366, which gave me no solution, or the sine of x could equal 0.366, which when I did the sine inverse, I got 21 degrees. So that's one of my solutions, okay? Now, another solution, because I took the sine of 21 degrees and got a positive ratio, 0.366, right? Because 21 degrees is in quadrant 1, right? Sine of angles in quadrant 1 and 2 will always be positive. 3 and 4 will always be negative. And you can remember that by doing ASTC. All students take calculus. So also find the angle in quadrant 2 by taking 180 and subtracting the reference angle. And then I have another solution that satisfies this original equation here. Right, so my two solutions are going to be 21.4691 degrees and 158.531 degrees. Now you can always check your solutions by graphing both sides and seeing where they intersect. So if I do 2 times the sine of x and then square just the sine of x, because that's what 2 sine squared means, and then plus 2 times the sine of x, and then minus 1, right? And then I'm looking for angles between 0 and 360. So I want to make sure that my x-axis is between 0 and 360, and also that it's representing angles in degrees. So I have to change my graphing angle to degrees. Okay. Now, if you're graphing in degrees, to change that, you go Menu, Settings, and then Graphing Angles right there. Change it to degrees, hit OK. Then you could take your window and view x only between 0 and 360. And we see that there are two solutions here and there. And if you remember what our two solutions were, they were like 21 degrees and 158 degrees. And if you look at the two places where it crosses the x-axis, meaning where 2 sine squared plus 2 sine minus 1 equals 0, all right, it's the same two solutions that we got when we did this without graphing. Right, you can always check your work by graphing both sides of an equation and seeing where they intersect. All right? And there's only two solutions here because it only crosses the x-axis twice. And the reason why we're looking at the x-axis is because that's where it equals 0. Right? So, stop me if you have a question. Let's do another one. So for number 2, we first try to factor this, but we see that we can't factor it. Cosine squared minus 3 cosine minus 1 can't be factored, because if you looked at this as like a quadratic equation, like x squared minus 3x minus 1 equals 0, all right, you can't factor that because there aren't two numbers that multiply to -1 and add to -3. So we have to do the quadratic formula. So I'll do that on my calculator. So I'll do control division to get my fraction bar, and then do the opposite of b. So b is the coefficient in front of the cosine of x. A is the coefficient in front of cosine squared of x, and c is the constant. So the opposite of b would be 3 plus the square root of b squared, so -3 squared, which is 9, minus 4 times a times c, all over 2 times a. And I get that number, which the decimal is 3.302. If I do the same thing, but change it to negative b minus and hit control division, I get my other solution, which is negative 0.302. So by doing the quadratic formula, I've now got this down to the cosine of x could equal 3.3, or the cosine of x could equal negative 0.302. Okay, if we look at this, we're going to have no solution, because again, cosine of x can only equal numbers between 1 and -1. So 3.3 is too big. If you imagine graphing y equals the cosine of x, that would oscillate between 1 and -1. And then 3.3 would be somewhere up here, and they would never intersect. So if you get numbers outside of the range 1 and -1, then no solution. All right, for this now, we're going to look for two angles that are in quadrants 2 and 3, because for cosine, it's positive in quadrants 1 and 4, but negative in quadrants 2 and 3. And we're trying to find an angle where if you take the cosine of it, you get a negative. So they should be here and here, okay? And both of them should have the same reference angle. To find the reference angle, we're going to do the cosine inverse of the absolute value of this ratio. So positive 0.302. And then once we get that reference angle with the calculator, then our two angles will be in quadrants 2 and 3, but with that same reference angle. Okay, so now I'm going to take the calculator and do cosine inverse of 0.302. It's going to be this number here, but the absolute value of it. And I could just either put it in absolute values or just erase the negative. And I get 72.37 degrees. So my answer is going to be in quadrant 2 or 3 with that reference angle. So it could be 180 minus that reference angle, or 180 plus that reference angle. Right? And I get those two solutions. Now, I showed you before that you could check your work by graphing. All right. You can also check your work by just plugging these angles back in. So if I did the cosine of x, but instead of x, I used one of my solutions and then squared it. That's what it starts off as, cosine of x squared, minus 3 times the cosine of x. But instead of x, I used that same angle, right? And then I did minus 1. Right? It doesn't say 0, but this number is essentially 0. Right? The calculator has trouble like getting exact numbers, and it's because I'm not plugging in exact radians, I'm putting in rounded degrees. This number is 0.000000, 14 times 5. So this number is like scientific notation. It means write -5, then move the decimal place to the left 14 times. And that's how you get a number that's really close to 0. All right. And then you can check the other one by plugging in the other angle. By plugging in like 252.376. And then here, plugging in the other angle, 252.376. And you get another number that's really close to 0. Not as close because I rounded more, right? And that's why we like to use radians. When you get to calculus, you want to be exact. When you do degrees, you're often rounding because pi is irrational. It's a decimal that goes on forever. But whereas radians could be kept in terms of pi, thus could be expressed exactly. Sort of like how you could say the square root of 2 is an exact number, like it's the square root of 2, but if you round it to like 1.4, like that's not exactly equal to the square root of 2, it's close to it, all right? So that's why we have those rounding errors there. All right, number 3. So now we have a quadratic, but it's not in standard form. So we're going to start off by putting this in standard form, all right? And this is all the same skills you learned in algebra 2. It's just now, instead of having x, we have the sine of x. And then, so instead of solving for x, we solve for the sine of x first, and then do what we learned in trig to bridge the gap to the final answer. So to put this in standard form, I'm going to add 4 sine squared of x on both sides, and that's what I have. Okay, now if I go to factor this, I'll find that two numbers that multiply to 3 and add to 4, I think two numbers that multiply to 2, because AC is 2, and add to 4. I don't think those numbers exist, if integers. So we have to do the quadratic formula. So I'll let the calculator do the hard work. All right, now remember that I added 4 sine of x on both sides. So you have to put the quadratic in standard form before you try to solve it. So this is the quadratic I'm trying to solve, but I've used x instead of the sine of x. So in the quadratic formula, I get control division, all right, the opposite of b, plus or minus, so we'll do plus first, the square root of b squared minus 4ac all over 2 times a. Two and two, they have to multiply to 2 and add to 4. So 2 and 2 doesn't multiply to 2, but it's a good guess. So, I mean, in worst case scenario, let's say you tried it and it didn't work, then all right, then you do the quadratic formula anyway. Or let's say you do the quadratic formula when you could have factored it. It's not a big deal. You're going to get the same answers. All right, but I like that you're thinking about different numbers. So hit enter here, and we get one of our answers. All right, so there's one. So we have the sine of x could equal that. Or, remember, it's the quadratic formula, so it's plus or minus. It could be that. All right, now again, if we were dealing with tangent, it would be a different story. But with sine and cosine, they can only equal numbers between 1 and -1. So we're trying to solve, all right, the sine of x equals that, and the sine of x equals -0.29. All right, oops, I didn't mean to type it like that. All right, now this can't be solved, okay, because if you graph y equals the sine of x, and again, it looks weird because our graphing angle is in radians. So or degrees. So if I change it back to radians, this will look like normal. And if I graph like 1.7, right, it's never going to intersect. So I throw this away. I don't have any solutions there. All right, for this, I got to find 2 angles. Now in quadrants 3 and 4, because the sine of angles in quadrants 3 and 4 will be negative ratios, right, that satisfy this. So I'm going to take the sine inverse oops, I didn't mean to do that. I'm going to do the sine inverse of the positive ratio, 0.292893. And I get 17 degrees. So I know that the sine of this angle will give me the ratio that I need, but the positive version, not the negative version. If I did 180 minus that reference angle, it would also give me positive 0.2928 because that's in quadrant 2, where sine is negative. So I want to do 180 plus that reference angle. This angle here is one of my solutions. So 197.031 is one of my solutions. All right. And then the other solution would be 360 minus the reference angle that we got from doing the sine inverse of 0.2928. And that's the other angle, 342. And if I check it, the sine of 342 also equals that ratio. So these are my two solutions here, 197.03 and 342.969. So once you do the quadratic formula and get your two solutions, right, if that number is between 1 and -1, then we're going to work with it. If not, it's no solution for that part. And if it's in between 1 and -1, we take the sine inverse of the absolute value of that ratio to find the reference angle, and then think about which quadrants the angles could be in based on whether the ratio is positive or negative. So in this case, it was sine equal to negative. So that has to be quadrants 3 and 4. So then we use the reference angles to find the angles in quadrants 3 and 4. All right, one last one. So we have another quadratic. It's not in standard form. So I'm going to get everything over on one side so that it is in standard form. Okay. And again, we have to find two numbers that multiply to 2 and add to 4. So it could only be 2 and 1, and that adds to 3. So we have to do the quadratic formula here. So I'm going to do that on the calculator. So I'll do the opposite of b. So b is negative 2. Well, I have to, let me write this out first. So when we added 2 cosine squared to both sides, it became 2x squared minus 4x plus 1 equals 0. But instead of x, it was the cosine of x. So that's what happened when we added 2 cosine squared to both sides. All right, now do the quadratic formula. So control division. All right, the opposite of b is 4 plus square root of b squared. So negative 4 squared is 16 minus 4 times a times c, right? All over 2 times a. Hit control division. And I got one solution. So the cosine of theta could equal that. Or if I do minus, cosine theta could equal 0.2928. All right. And now this solution we could throw away because cosine theta can't equal anything greater than 1 or less than -1. And now we have to find the cosine of x is equal to that. So I'm going to do the cosine inverse of that. Get the reference angle is 72.96 degrees. All right. It is very similar to number 3. It's like the same numbers, but it's cosine instead of sine. But yeah, very similar. Now, I was thinking the same thing. All right. Now we got to find the angle in quadrant 4 because it's the cosine of x equals a positive number, which ASTC, cosine positive in quadrants 1 and 4. So the other solution would be 360 minus 72. I'll just copy that. Minus. If you arrow up, it'll highlight it, and then enter will copy and paste it. So that's our other angle, 287.03. So those are our two solutions. And yeah, it's pretty nice when you get when you do the quadratic formula and you get a number bigger than 1 or less than -1, because then you could just throw that solution away and then work on the ones that are in between 1 and -1. And do your inverse. All right, always do the inverse of the positive ratio to get the reference angle. In this case, 72. Then use the reference angle, whatever quadrants the angle's in, based on the sign, meaning positive or negative, and then go from there. All right, so that concludes these notes. So I'm going to end the video.